Hello everyone, this is lesson 7.4 on special right triangles. So in this lesson we're going to discover a few different shortcuts in calculating with right triangles. So 7.4 special right triangles. Okay, and this is part 1. We're just going to do a little investigation, and then the next lesson will have some more complicated examples. So we'll be using the Pythagorean theorem to discover some relationships between the sides of two special right triangles. There are many problems involving these triangles in standardized tests and college entrance exams. We can also apply these ideas with trigonometry. So and I can't emphasize that enough. When you get to trig, you'll use these concepts. So the first, and also we'll be kind of using our understanding of simplifying radicals again in this lesson. Okay, so be prepared for that. So the first special right triangle involves an isosceles right triangle. So for this isosceles right triangle, what is the measure of angle CBA and CAB? Well, if they're isosceles, then they both have to add up to 90 and be the same, so they're each 45. And fill in those values into the diagram. Okay, so hopefully you're writing these notes down as you go. All right, and then we're going to give some examples. So down below here, you've got quite a few examples, and maybe we'll just do a couple of these and then talk about the pattern. Normally in a lesson, I would have you do all of them in class, and then you kind of figure out in your groups what the pattern is, but I will probably kind of shortcut that so to make the video a little shorter. So let's say that A is 3 in this triangle, so B also would be 3. Okay, now to calculate C, you would do Pythagorean theorem. So 3 squared plus 3 squared equals C squared. 9 plus 9 is 18. And then we would take the square root of 18, which we would break up into 9 and 2. So the 9 comes out as a 3, and the 2 stays in. So this would be 3, 3, and then the hypotenuse is 3 square root 2 for 45. We call this a 45, 45, 90 triangle. 45, 45, 90 triangle, right? Let's say A is 4. Okay, so if A is 4, then B is also 4, and let's calculate C. So let's do 4 squared plus 4 squared equals C squared. So 16 plus 16 is 32. Take the square root of 32, which can be broken up into 16 and 2, and the 6 comes out as 4 square root 2. So the hypotenuse here is also 4 square root 2. I think I was writing this in the wrong. I think this goes up here. Oh well. Okay, so 4 square root 2, 3, 3, and then 3 square root 2. You might be wondering if there's a pattern involved here. Let's do maybe one more to double check our pattern. So let's say that A is 5. So B is also 5. So we'll do 5 squared plus 5 squared equals C squared. So that'd be 25 and 25 make 50. Take the square root, break it up into 25 and 2. So the 5 comes out as 25 comes out as a 5, and the 2 stays under. Okay, so it looks like we've got a pattern here. So if your legs in a 45, 45, 90 triangle, if your legs are whole numbers, then the hypotenuse is just going to be that number times the square root of 2. Right? And I think the rest of these are the same. Yep, so it gives you just a different number. So this would be, if this is 7, this would be 7, and this would be 7 square root 2. If this was 8, this would be 8, 8, and 8 square root 2. So make a conjecture about the pattern of the relationships between the lengths of the hypotenuse and the length of the 2 legs of each of the problem. Fill in the blank with the term x. So in an isosceles right triangle, if the legs have a length of x, then the hypotenuse has a length of x times the square root of 2. So here's your little diagram for the general case. So if this is isosceles right triangle, and this is 45 and 45, this is x and x, then the hypotenuse is x times the square root of 2. All right. Let's do the 60-90 triangle. So let's assume, start by using a little deductive reasoning to reveal useful relationships within 30, 60, 90 triangles. So the triangle right here is equilateral, so that means these two lengths are the same, and that means all three of these angles are 60, so this is 60, and this is 60, and you also have an altitude, but you know that if an altitude goes through an equilateral triangle, then it is also an angle bisector and a perpendicular bisector. You learned that in Unit 5, I think. Yep. So these two would be the same, which if this is 60, these would be 30. And then these two would be the same. I'm going to mark them with something with 2 ticks. And this would also be, so you've got two right triangles that are 30, 60, 90. Okay. So also, hold on a second. What are the measure of angle A and B? So A and B are 60. What are measure of angle ACD? So those are 30. And then ADC, those are 90. And then, yes, they are congruent because of, what could you say here? Angle, side. Okay, there's lots of different ones. You could use angle, side. And then, is AD congruent to BD? So yes, because it's an isosceles triangle. So what we're going to do is we're going to assume that AD is X and BD is X. So if AD and BD are both X, then the whole side would be 2X, which means that the hypotenuse here is 2X if the short leg is X. So we're going to do a little bit of math here. We're going to do X squared plus, and we're going to call this something that we don't know. So let's call it A squared, and then equals the hypotenuse, which is 2x squared. Okay, so 2x squared would be 4x squared, and if you subtract this x squared over, you get 3x squared. So we have a squared equals 3x squared. And then if we took the square root of a to solve for a, you would get a equals the square root of 3 times x. So whereas the other one, the relationship was x square root 2, this relationship is going to be x square root 3, and 2x, or square root 3x. Either way, you can write that. So let's do a couple little investigations here. So let's see what you can discover. So find lengths of the indicated side using the conjecture you just made above. So this is A, this is 34. Okay, so if this is 34 and this is A, then this is the short leg, because it's opposite of the 30-degree angle, so that'd be half of the hypotenuse, which is 17. All right, for this one, this is also the short leg, 9, so the hypotenuse would be twice as long, 18. Okay, here, if the hypotenuse is 66, then the short leg is half of that, so 33. All right, so the rest of them are kind of the same. So what we're going to do next is we're going to go back through these and find what the long leg would be. So let's do that. So we're going to find this long leg if we know that this is 34 and 17. So 17 squared plus, we'll call it b squared, equals 34 squared. All right, I'm going to take my calculator. 34 squared is, well, I just subtract 17 squared from both sides. Minus 17 squared is 867. This might not be the most practical way to do this, but let's see. 867, what can we divide that by? That's a perfect square. How about, well, I kind of already, hold on a second. Okay, 876 can be divided into 289 and 3. And I don't expect you to know that, but I guess just for this purpose, 289 and 3. The reason I chose 289 is because it is a perfect square of 17. Okay, so I didn't just kind of make that up from thin air. I remembered that, okay, 17 is going to be important here. So the 289 comes out as 17, square root 3. Okay, so it does work out. And just so I don't kind of waste your time here, we're just going to leave it at that. Okay, I'm not going to walk you through the discovery process that I would normally do in class. So here, for this one, the long leg is 17 square root 3. So what would the long leg be for number 2? Well, if the short leg is 9, then the long leg is x times the square root of 3, which would be 9 times the square root of 3. Here, if the short leg is 33, then the long leg is going to be that times the square root of 3. All right, so just one little summary here at the bottom. So for 45, 45, 90 triangles, okay, you can mark up the diagram. The relationship is x square root 2, and it might be helpful, sorry, this is supposed to be 2, might be helpful to also draw a little diagram here when you're problem solving. Why do I keep writing the 3? And then for this one, this is 60, 90, 30. For this triangle, it's going to be x for your short leg, x square root 3 for your long leg, and 2x for your hypotenuse. So x square root 3, and 2x. Okay, and then this little chart here is going to be helpful to put the numbers in so you don't lose track. All right, so the examples that you're going to do tomorrow are going to be just very basic, and then the next video I'm going to have you watch is going to show you some more complicated types of problems that you will solve in a little bit more math, and also you'll learn about how to simplify a radical in the denominator in the next lesson. Okay, so I'm going to leave this video at that, and I hope you guys have a great day.